Okay, so number 7. A ball is thrown upward from the ground. After 0.7 of a second, it reaches a window which is 0.8 meters in height. It takes 1.1 seconds to pass the window. With what velocity was it thrown? What are the two parts to this question? Before the window and the window. Okay, so here we are. So a ball is thrown with some initial velocity, which we don't know. But we know A is 9.81 meters per second squared down. It says after 0.7 of a second it reaches the window. So delta T is 0.7 of a second. It reaches a window that's 0.8 meters in height. So the window itself, delta D, is 0.8 meters, and that's going up. It takes 1.1 second to pass by the window. Delta T is 1.1 seconds. The acceleration of this part is also 9.81 meters per second squared down. Now, you cannot assume in this one that the VF is 0. It doesn't tell you that it stops when it gets to the top of the window. So we have to assume it continues to go. Okay, so what connects both parts? The VI of the window will be the VF for below the window. We don't know them, but if we can get one, we have the other. So where do we start? Well, we should start with the window because we only have one unknown. Below the window, we have two. So we have an A, a delta T, a delta D, and we want a VI. So delta D is equal to VI delta T, 1/2 A delta T squared. And again, you're going to rearrange for VI, so delta D minus 1/2 A delta T squared equals VI delta T, and then divide both sides by the delta T. So delta D minus 1/2 A delta T squared over delta T. This time we have an up and a down, so because the ball's going up. So we have to call one of them negative. Let's call down negative. So 0.8 meters is up, so it's positive. Minus 1/2, the 9.81 meters per second squared is down, so it's negative. And the time was 1.1 seconds, and remember you're squaring that. And then you're dividing by 1.1 seconds. And when you do that, you should get a VI of 6.12277 meters per second. So that's the VI of the window, which means it's the VF of below the window. And now that we have that, we want our VI of below the window. We have the VF, the A, the delta T. We can just do VF minus VI over delta T. Okay, rearranging. A delta T is equal to VF minus VI. And you want the VI, so I'd bring the VI over here so it became positive, and the A delta T to the other side so it would be negative. So it'll be VI is equal to VF minus A delta T. So VI equals, VF was what you have in your calculator, 6.12277 meters per second, minus A, which was down, so negative 9.81 meters per second squared, and the time for this section was 0.7. And when you do this, you get a VI of 12.9898 meters per second, works out to be positive. That is up. This one also worked out to be positive, so up. Okay? One more. Number 8. I'm So Speedy is running at 4 meters per second when he sees a crazy physics teacher directly in his path, 6.2 meters in front of him. It takes I'm So 0.5 seconds to decide he'd better slow down so that he doesn't run into this crazy physics teacher. He can only slow down at a rate of 2 meters per second squared. Will he run into the teacher? What are the parts? There's his reaction time and then his slowing down time. Okay? So reaction time. So what do we know about that? He's running 4 meters per second. So in his reaction time, that's his VAV. When he sees a crazy physics teacher, it takes him 0.5 of a second. So that again, to decide to slow down. So that's his time under reaction time. So then he decides to slow down. So his VI is 4 meters per second. And it says he could slow down at a rate of 2 meters per second squared. And he's going to slow down until he stops. And the question wants to know, will he run into his teacher who is 6.2 meters in front? So you need to find the two delta D's, then add them together. If they are greater than or equal to the 6.2 meters, physics teacher's in trouble. So for the reaction time, VAV is equal to delta D over delta T. So delta D is equal to VAV times delta T. So our D1 is going to be 4 meters per second times 0.5 of a second. So D1 is 2 meters. Over here, we have a VI, an A, a VF, and we want a delta D. So VF squared is equal to VI squared plus 2A delta D. Rearrange for delta D, VF squared minus VI squared, and then divide by the 2A. So delta D2 is equal to VF is 0. So subtract 4 meters per second, and that gets squared over 2 times negative 2 meters per second squared. So this will be negative 16 meters squared per second squared, and this is negative 4 meters per second squared. 16 over 4 is 4. The negatives disappear. So D2, 4 meters. Total distance then, add them together. D1 plus D2, 6 meters. Does he run into his teacher? No, he doesn't. Close, but not quite. Okay, so hopefully you're getting a hang on how to set these up, how to link the two parts, and now you have an assignment you can